Question number 3. An experiment consists of drawing a card at random from a deck of 52 cards. The following are the 4 possible events. So A, you can obtain a face card. That's a card with a face on. Kings, queens, and jacks. They're the only face cards. There's 3 per suit. There are 4 suits. 3 times 4, there are 12 face cards. So A, obtaining a face card. B, obtaining a king. That's a king. C, obtaining a red card. So hearts and diamonds. So half the deck is red, half the deck is black. Obtaining a heart. That's a heart. There are 13 of them. The probability of B given A is equal to the probability of the intersection between B and A divided by the probability of A. The probability of A intersection B divided by the probability of A. The probability of A intersection B, getting a face card and obtaining a king. What's the probability of getting a face card and a king? Anytime you get a king, you have a face card. How many out of the 52 cards, face card kings are there? Well, there are 4 of them. So 4 out of 52. The probability of A, obtaining a face card. There are 3 face cards. There's the king, queen, and jack. And there are 4 suits. 3 times 4, there's going to be 12 out of 52, which reduces to 3 out of 13. In any suit, there are 13 cards, and there are 3 face cards. We have 4 out of 52 divided by 3 out of 13. Now, I've rewritten the 4 out of 52 as 1 out of 13. Divide the top and bottom by 4. You get 1 out of 13. So I have 1 out of 13 divided by 3 out of 13, which is 1 out of 13 times the reciprocal of 3 out of 13, which is 13 over 3. The 13s are going to cancel, and I have 1/3 as my answer. That's it for A. For B, the probability of B given C. So the probability of B given C is the probability of B intersects C divided by the probability of C. The probability of B intersects C, that's like, the probability of getting B and C. Obtaining a king and obtaining a red card. There are 2 red kings. The king of diamonds and the king of hearts. That's 2 out of 52 cards. The probability of B intersects C is 2 out of 52. The probability of C is obtaining a red card. Half the deck is red. Half. Or you could say it's 26 out of 52, which is the same as a half. We're going to have 2 out of 52 divided by 1/2. 2 out of 52, I've reduced it to 1 out of 26. 1 out of 26 divided by 1/2. When dividing by a fraction, we multiply by the reciprocal, so we have 1 out of 26 times 2 over 1. The 2 and the 26 are going to reduce. That gives us 1/13. That's it for 3B. For 3C, the probability of B given D. The probability of B given D is the probability of B intersection D divided by the probability of D. B intersection D is obtaining a king and obtaining a heart, getting the king of hearts, which is 1 card out of the 52. The probability of B intersection D is 1 out of 52, divided by the probability of D, obtaining a heart. 1/4 of the cards are hearts, so we can say 1/4. 1 out of 52 divided by 1/4, which is 1 out of 52 times 4 over 1. 4 goes into 52 13 times. That gives us 1 out of 13. 3D, the probability of C given A, which is going to be the probability of A intersection C divided by the probability of A. A intersection C is obtaining a face card that is a heart. So there are 3 face cards that are hearts. Obtaining a face card and obtaining a heart at the same time. So there are only 3 of them out of the 52. So the probability of A intersection C is 3 out of 52. The probability of A intersection C, A is obtaining a face card, C is obtaining a red card. King, queen, jack of hearts, the king, queen, jack of spades. That's 6 cards out of 52. The probability of getting A and C, of getting a face card that is red, is 6 out of 52. The probability of A, just getting a face card, is, if we're looking just at one suit, 3 out of 13. But if we're looking at the whole deck, that's 3 in each suit. There are 4 suits. That's 12 out of 52. But I'm going to go with the 3 out of 13. So I'm going to have the 6 out of 52 divided by the 3 out of 13. Probability of A intersection C is 6 out of 52. The probability of A is 3 out of 13. So 6 out of 52 divided by 3 out of 13, which is 6 out of 52 times the reciprocal of 3 out of 13, which is 13 over 3. The 13 goes evenly into 52. 4 times. The 6 and the 4 are going to reduce. We're going to get 3 over 2, and the 3 is going to cancel, leaving us with 1/2. For E, the probability of C given B is the probability of B intersection C divided by the probability of B. B intersection C, obtaining a king, obtaining a red card, so getting a red king. There are 2 red kings, king of diamonds and the king of hearts, out of 52. So the probability of getting a red king is going to be 2 out of 52. The probability of obtaining a king, there are 4 kings out of 52 cards, which reduces to 1 out of 13. There's 1 in each suit. There are 13 cards in a suit. 4 out of 52, 1 out of 13, same fraction. Quick equivalent fraction. I'm going to have 2 out of 52 divided by 1/13, which is 2 out of 52 times the reciprocal of 1/13, which is 13 over 1. The 13 cancels with the 52, leaving us with a 4. The 2 and the 4 we're going to reduce to give us 1 over 2. We end up with 1/2. That is it for 3E. 3F. The probability of D given C is the probability of D intersection C, or C intersection D, doesn't matter, divided by the probability of C. C and D, obtaining a red card and obtaining a heart. You have two kinds of red cards. You have hearts and diamonds. But they're saying you win only if you obtain a red card and a heart, which means all hearts. The probability of getting a heart is 1 out of 4. There are 4 suits. Only 1 suit is hearts, or there are 13 out of 52, which is still 1 out of 4. Now, the probability of C obtaining a red card, half the deck is red, 1/2. So I have 1/4 divided by 1/2, which is 1/4 times 2 over 1. The 2 and the 4 are going to reduce, leaving us with 1/2. And that's it for question number 3. Have a good day.